Uh, now, find the volume of spheres increasing at the rate of this much. Find the rate of increase of the radius when it is 6 centimeters in length. Okay. What we're going to go for is dv dt. Please pay attention. All right. So what we have is dv dt is change of volume with respect to time. Dv dt is 24 pi. It says find the rate of increase of the radius. So what we want to find is dr dt. Is everybody happy? We want to find dr dt. Now, the goal is to find dr dt. So there's dr dt, which means you separate dr and you separate the t. What's the only other letter in this question? So it means I need dr dv, and I also need dv dt. Now I have dv dt, but what I don't have is dr dv. So what I can do is get dv dr though. Let's see what we can do with it. What shape is it? Sphere. Sphere is 4 over 3 pi r cubed. Then what's the VDR? 4 pi r squared. Using that logic, what is the RDV? The RDV is 1 divided by pi r squared. Everybody see what I did? What's the r value? 6. So what's 1 over 4 pi 6 squared? 36 times 4? 144 pi, is that right? Now I can fill out the RDT. The RDT is the RDV, which is 1 over 144 pi. What's the VDT? 24 pi. What's 24 divided by 144? 6. Did anybody get 1/6? Nobody? Now what's the units? What's the units of radius? What's the units of time? Centimeters per second. Is that alright? Alright, let's go for 11. Alrighty. Okay. The y dt is what is the y dt the same as? What's the only other letter available in this question? Huh? Ex, exactly. Now, we have the x dt, don't we? What's the x dt? Tan root 2. Do we have the y dx? We don't, do we? So what is the y dx? So you differentiate 1x, you get? What you get? 1. That minus 1 over 40. Now obviously you differentiate x squared. 2x. Okay, and what you get then? What's the value of x in this question? 10. So what's 1 minus, that's going to be 20 over 40. 1 minus 20 over 40 is a half. Is that right with you guys? So what's a half of 10 root 2? A half of 10 root 2, lads? 5 root 2. And you're done. Who got 5 root 2? Alright. Happy days. Alright, we'll have a look at 13 now. Oh, that's not 13. Question, yes? Right. A 10-meter ladder leans against a vertical wall. Right? So no matter what, the ladder is 10 meters. Okay, can't really change that. Now, the top of the ladder is at a height 8 meters up the wall and is slipping down the wall at a rate of 1 meter per second. At what rate is the foot of the ladder sliding along the ground when the top of the ladder is 8 meters up the wall? Oof. Yeah, it is a bad ladder. Alright. Would everybody agree that y is the height? y is the height, and x is the width. Okay? But everybody agreed are bounded by the following equation. X squared plus y squared equals 10 squared y. Alright? So did everybody agree? So x squared plus y squared equals 100. Everybody cool with that so far? Alright. Now, I would argue that the y dt is what? What do you think the y dt is? So, plus 1 or minus 1? Why is it minus 1? Anybody? Sliding down, so I'd say it's minus 1. We're going to check the answer at the back of the book because I haven't done this question before. I didn't research it either, so here we go. Now, what's the next part I'm looking at is, I think the whole point of the question is to find the x to t. Why do I think that? What rate is the foot of the ladder sliding along? So that to me means the x to t. It doesn't necessarily say so. It says it in a fancy way. It doesn't say find the x to t. It says find that. Okay. Now, it also says that the y value is 8, which is good to know. So, would everybody agree that we're looking for the x dt? Alright, so what does that mean? Put the x here, put the t here. What's the only other letter in our question? So, now we have a clear way to go, don't we? Now, we can get the y dx and just turn it upside down, but there is an issue. We don't know the x value, but we do know the. Okay, so that won't help. Here's actually my suggestion. It's a weird one, but we're going to go for it, right? So, instead of getting y in terms of x, I'm actually going to get x in terms of y. So, x squared is equal to 100 minus y squared. You kill with that? What do we do to both sides? Square root. X on its own is the square root of, technically plus or minus as well, right? Yeah, and it's the square root. We won't mind the plus or minus at the moment. 100 minus y squared. Everybody cool with that? Now, next thing, what is 100 minus y squared? It's 100 minus y squared to the power of a half. Now, we're going to differentiate it. So what's the next one going to be? Is it going to be the y dx or dx to y? Dx to y this time. Because it's x in terms of y, not y in terms of x, okay? And what happens to the half? Goes to the front, and what do we get then? 100 minus y squared stays the same, and then what do we do with the bracket in the middle? You differentiate that part in the middle. I forgot to minus the half, didn't I? And what do you do with this part here? Minus 2y. Now what's the y value? The y value is 8, so I'm just going to sub in 8 right now. So it's going to be 100 minus 8 squared. 8 squared is 64, isn't it? To the power of minus a half. And then beside that is going to be minus 2 times y, so minus 16. Okay with you guys? Okay. Now, and the answer will be minus 4 over 3. Okay with that? So you sub in y equals 8, and you get minus 4 over 3. If I got y in terms of x, I had no chance to sub in x because it doesn't tell me the x value, does it? No. It doesn't tell me the x value. Yeah. Grand. I'll have a different way of doing it. But anyways. The x dt is what then, guys? Minus 4 over 3. And what's the y dt? Alright, well somebody check in the back of the book, is the answer 4 over 3? Is it? Alright, should not be so surprised, but yeah, we got it right. Alright, we all agree it's a circle, right? And what are the two formulas you see on your circle, underneath your circle on your tables? What do you see? You see 2 pi r for the circumference or the length. In this case, it'll be C equals 2 pi r, and you also see A equals pi r squared, okay? Now, I want you to find out what the CDA is. No bother, the CDA. And then what I do is I do what we've always done. Separate the two letters out and pick the third letter. What's the third letter? What is it? DR and what? DR, right? I think this question has an extra layer on it. What's this mean? DA, DT. How many letters do we have this time? I'm counting 4 letters. There's T as well, so this is why it's the last question. This is why Connor always bets on the last question, because he throw up a hard one at the very end, okay? And what does it say underneath that then? Find the rate of increase of the circumference when the radius is 3. So it wants us to find the C, the T, when R equals 3. Alright, let's start off with part 1. There's 2 parts to this question. There's the top part and the bottom part. Let's stay with the top part. Okay? Does anybody know how to get to CDR? Anybody know how to get to CDR? Differentiate the circumference formula. What you get? Plus 2 pi. Does anybody know how to get the ADR? Differentiate the area formula, and what do we get? 2 pi r. How do we get the RDA? Upside down. Finally, do we have enough to answer part 1? What do we have then? 2 pi and 1 over 2 pi r. And what's the answer then? Is that what we're asked to prove? It was. Pause it there. The goal of the question is to find the C to T. Everybody see the C to T? So the C to T, same as what? The C, the T, and what letter do you think we're going to use? I think we're going to use the A, and I'll explain why. We already know what the A to T is, don't we? What is the A to T? 2. What's the CDA? It's up here. What is it? It's 1 over r. And what's the size of the radius? So what's 1/3 times 2? No, 2/3. And what units are we dealing with? Centimeters per second.